So we were going to do a little bit at the end tonight on multiplication and division, but just before we go on to there was a question in the car park last time which was asking about, is there good active games or activities when talking about regrouping in addition? And I think one of the things that we thought about when we started thinking about this question was, if, for example, we pose an addition question that has regrouping, we could have every child in our class get that correct, and actually they've all answered it in lots of different ways. So you could have children who are using the likes of jump, so jumping up in tens and then in ones. They might split it, so they might be adding the tens first and then the ones. They might round up, where they're going up to the nearest 10, so up to 40, and then adding the remaining ones on. They might be able to compensate it, so they're changing it into slightly friendlier numbers to work with. And then we might have children that are transforming the numbers completely, so they can think in terms of how flexible the numbers are and how they can change them to make them easier to calculate mentally. So really, one of the important things to think about is when you are teaching regrouping and addition, it's important to be having the discussion not just about getting them to solve the questions, but actually that discussion around how are they solving it. Are you talking about strategies? Are you sharing strategies? Are they getting that opportunity to model the strategy that they're using, to learn from each other? And so that's kind of one of our key points when kind of thinking about regrouping. But we also have put up some examples on the next slide which could be used to help you reinforce. So things like using 100 square, you might get them to count from this number to this number. How did they get there? What did they add? Did they add the tens? Did they add ones? Can you think of another way to get to that number? Screen counting, so using things like 100 dot cards, 10 dots, and then the ones that have got like 1, 2, 3, 4, and screening them so that learners are counting. They're counting up in hundreds, counting up in tens, counting up in ones. Hopefully you're all familiar with loop cards, so that's where you go round a group or the class. So somebody starts, they all calculate that, and if they've got the card, in that example there, they would say, well, I've got 62, then my question is 55 plus 49, they all calculate that, then the next person says, oh, I've got that answer, and so it goes round. What went wrong example, so where you purposely maybe write out a question where there is a mistake in it and you're having that discussion, what has happened, where has it gone wrong, what might this person's misconception be. And also if you're wanting them to be able to play games independently where they're generating their own numbers to add or subtract, using a random number generator, so you can get these online, or it might be that they pull flashcards out of a bag, or I used to have bingo balls that they would take two bingo balls out and then they would write a question out, that way they can generate their own addition or subtraction questions, or they might work in pairs or a small group and then solve that question and then discuss their strategy. So hopefully that answers that question from last time. And then tonight, as I say, we are going to focus on multiplication and division. If you missed the recording or missed the live session from last time, we would suggest that you do go back and watch this. And I noticed a couple of the comments in the evaluation saying, are the sessions recorded? Yes, they are. And they're available on the Padlet. So if you've not watched the last session, we would advise that you do go back, because we covered grouping and sharing in much more depth, and we're going to kind of reinforce that tonight. And one of the other things that we will link back to is when we think about multiplication and division, we're also needing to think about counting. And we talked a lot about counting in our number and number processes session, but it is important that when you're teaching multiplication and division, you're also starting to count in sequences. So you're counting in 2s and 5s and 10s, and that way the learners are becoming familiar with hearing these number patterns and hearing them being said forwards and backwards, so 2, 4, 6, 8, that kind of thing. And there's lots of different counting games that you can play. You might miss out a number in the sequence and ask them what comes next. The learners get to hear your voice counting when you say the pattern, so you might start the pattern 2, 4, 6, X, and then they continue with what comes next. And there's also lots of different visuals that you can use, so things like socks, hands, dice pattern, 10 frames, which help to reinforce that visual, of adding 10 each time or removing them if you're counting backwards, or, adding 5 every time. And like, if you're further up the school, you'll be counting in 3s and 4s and 7s and 8s. So it is really important that when we're talking about multiplication and division, we are making these links back to the addition and subtraction, and also to the number and number process skills. I'm going to hand over to Maria, who's going to highlight some of the kind of main points to do with multiplication and division that we'd really like to cover tonight.
Thanks, Yvonne. Thank you. So, just going to talk very briefly about times tables to start with. And we know that teaching and learning times tables can be tricky, and often learners just memorise the facts as they would perhaps the lyrics to a song. But what they might not have is that real depth of understanding. So when we think about the question of the calculation that's posed on the screen just now, so 7 multiplied by 6, can your learners visualise what that looks like when you ask them that calculation, or a calculation very similar? Can they link back to known facts that they've been taught, or approaches that they know that will help them unpick that calculation? And I suppose what we are promoting here is that when teaching times tables, we should be building on that prior understanding. So for example, use skip counting. We could rely on doubling or halving or partitioning, as this can make the calculation easier to solve, but it also demonstrates for you, the practitioner, what a learner does or does not know and understand. So we can see in the slide just now from the examples that are coming up that there are many ways to solve the calculation 7 multiplied by 6. We're going to share a few as you can see them popping up on the slide just now, but learners will come up with many more if you give them the opportunity and if they're prompted to do so. So just a couple of the examples are, they might skip counting 5s up to 35, and then they might partition the final 7 and add on a 5 and then a 2 to make the answer 42. They might rely on their understanding of the relationship between 3 and 6, so they might find the answer to 7 times 3 and then double the answer. And I suppose what's really important here is that by asking that type of question, how can you do this, what are all the different ways, learners are able to demonstrate their understanding, but it should give you that indication of, when you're planning next steps, what support and challenge is needed for individual learners or for groups of learners. So we're trying here to promote learners demonstrating what they know in a variety of ways. So that could be using concrete materials, it could be using visual representations, some of which you can see on the screen just now, because simply asking them what is 7 times 6 and then expecting them to say 42 does not support the progression of understanding, and it does not allow for the effective next steps in terms of support and challenge for learners. So we really want to dig a bit deeper than that and get out of their heads what's in their heads, so that we can then unpick that a bit further. So just moving on, we're going to talk a little bit about arrays. So do we teach explicitly to our learners, for our learners, what an array is? If we ask them that question, do they know that an array is a rectangular arrangement of objects used to represent a number in a way that can illustrate multiplication and division? Do they know that the objects are arranged in rows and columns? And we'll talk a wee bit in a second about what I mean by rows and columns. Using arrays can really support the understanding of the commutative law, and without modelling, that can be a really abstract concept for learners to understand. So it's as many opportunities as we can to really open up that thinking. What you'll see on the screen just now has been taken directly from one of our professional learning documents, so in this case the multiplication and division, and there are many more examples in that document, so I'm just going to put a link to it in the chat just now. So we would encourage you to go back to the professional learning document, in particular the section on multiplication and division, and look at the other examples that we've put in there of using arrays to support teaching and learning that will aid that understanding. So I mentioned earlier on the importance of learners knowing the difference between a row and a column, because if they don't have that, then they'll find it difficult to understand arrays. And again, it's about not assuming that the learners will actually know that we might need to model and explain that. So what we're trying to emphasise in this slide is effective ways to teach that commutative law that I spoke about in the last slide, that we're looking for the learners and giving the opportunities for learners to make the links, but in a very, very visual way. So rather than just say that 4 times 3 is the same as 3 times 4, we're actually giving the learners opportunities to see that in a very visual way and to play about with it, because that's when the learners will come to that understanding on their own through the doing. And I'm just going to pop in the chat just now a video that I've used before. And in the video, I've just put the link to it in the chat there. The video link's actually very good, because what it does is the practitioner in that case uses a range of resources. So I think she used bead strings and she uses counters, she uses money, and the learners themselves come to the realisation that 3 times 4 is the same as 4 times 3 by just shifting their whiteboard about where their coins or their counters are displayed. So it's that light bulb moment, and that video is actually very, very good to demonstrate that. Somebody's saying the link's not working, but yeah, I think Yvonne's answered that.
Yeah, that's the Glow link, but it's also on the hub, which means you don't need to be logged into Glow, so that's in the chat now.
Great stuff. So it's really worth a watch, just to give you some ideas about how we can teach that quite abstract concept, but in a really open, hands-on, practical way. So just move on, thank you. So we're just going to move on here to think about if learners do know 3 times 4, and what we're trying to do is really deepen their understanding. We're promoting them to think a wee bit deeper. They actually know a lot more than that, and that they can demonstrate that through the use of resources. So if we're always asking questions like, if you know this, what else do you know? We're really encouraging, again, the learners to think a bit deeper, maybe use some of their higher order thinking skills. So what we see here is we can see 3 rows and 4 columns. We can see 4 columns and 3 rows, depending on the way that we look at it. So we're leading the learners through that modelling and that explanation that 3 times 4 and 4 times 3 give you the same answer as 12. But what we also see is we see 12 counters in total, divided into either 3 rows and 4 columns or 4 columns and 3 rows. So again, we're modelling, and I would be recording that as I was going through this demonstration with the learners. So 12 divided by 3 is 4, and 12 divided by 4 is 3. It's making, again, any of these links to deepen that understanding. We could be making the links to fractions here as well, and I'll just go on in the next slide to demonstrate a little bit about what that might look like. So what I've sort of spoken very quickly about so far is making the learning visible, establishing links across learning so that learners can see the learning easier, and the learning is more likely then to be retained because it involves them doing, through investigating, sharing, discussing and seeing the links themselves. But it also provides you as the practitioner with a wealth of formative assessment information, which should lead to that effective planning, because it will take your learning and your teaching from where the learners are at. So we can see here that we can use that same calculation that I spoke about in the last slide, but we're starting to deepen that understanding that they can see the links to thirds and quarters as well, but much easier to do that through demonstrating it in a very visual way, as highlighted on the slide just now. Thanks, Jacqueline. Thank you. So yeah, just to kind of finish off almost this little section before I pass back to Jacqueline, your arrays can start, when you're introducing them, they can start quite simple and then build up eventually. You'll know your learners best, so you'll know when it's the best time to maybe introduce more complex examples. At second level, it's more likely the area model would be used because the numbers are then getting larger. An example of this we'll talk about towards the end of the presentation. But it's obviously better for learners to use real life objects where possible. But some of these images that you can see on the slide just now will be useful in providing some ideas that you can take forward in your own context. So using arrays can be used to promote better dialogue. So what you're trying to get is for the learners to think about, what do you see when you look at that? What do you see? What do you see? Do you see something different? And really open up that opportunity for the learners to share and discuss. There are some links at the bottom of that slide for some interactive games, which again use arrays to support teaching multiplication and division, but through the use of arrays. So again, we'd encourage you to have a look at those if that's something that you're going to be teaching sometime soon. And we mention, and we have mentioned throughout all our sessions, that multiple representations are the way forward almost, and we will continue to look at that and promote that, because this is a really powerful formative assessment approach. It allows learners to demonstrate what their current levels of understanding are. So open-ended questions such as, can you show me whatever, in lots of different ways to represent, for example, in this example 6 times 4, it can be really helpful if you try to get the learners, and I think there was a question in the chat earlier on, it's just about encouraging the learners to show you that in lots of different ways. Obviously some scaffolding might be needed for learners to include those representations, to include division. Can you show me this in another way? Again, encouraging the learners to rethink and explore alternatives. And can they show the associated fractions too? Again, you can differentiate this activity quite clearly. Again, you know your learners best. I'm going to stop there and pass on to Jacqueline, who's going to go through division in a bit more detail. So can I pass over to you, Jacqueline?
Thank you. So in the last session, we talked a lot about the 2 models of division, sharing and grouping. So I'm not going to talk too much about that just now, just so we can fit everything else in. But if you want a wee bit of refresher on that, then please do watch the previous presentation. And this is just showing it using some counters as well. So we also talked about a little bit about bar models in the last session, but it might be that you're sharing it equally by 4, or it might be that you're grouping it in 4s in these examples here. But this is just to show you how bar models can be used. And what I would say about bar models is some people love them, some people don't, and that's okay. Don't feel that you need to love what you're doing, using them, but try them and see how they go and see how things go. So what I wanted to do, this is quite a big, it was a new approach to me, so I'm going to try and take my time with this just to show you, and it might be that it kind of blows your mind a wee bit at the moment, it might not, but it's something that we could investigate a wee bit further in our regional meetings should people want to as well. So if you just have a wee think about this, consider 132 times multiplied by 6. So if we lay this out, and this is what's called the area model, so we've got 6 at the left-hand side, and we've got 132. What we're going to do is we're going to partition the 132 up. So we've partitioned it into 100, 30, and 2. And that's just purely to make it much more manageable. And what we're going to do now is we're going to multiply each partition. So 6 times 100 is 600, 6 times 30 is 180, and 6 times 2 is 12. And then what we're going to do is add them all up together. So that's possibly a different approach from what you've used before. Maybe some of you have been using it, and that's great. But what I find is it's just a way of showing learners a different way of doing it without that written formal algorithm. And it's almost that jump between using concrete materials and into the formal written algorithm. It actually just shows, well, why does 132 multiplied by 6 equal 792? Well, actually, if you look, this is how it can break down. So it's just a different way of looking at it as well. And as we say, we just cannot endorse multiple representations enough. Looking at it with more complex numbers, if you've got 2 digits by 2 digits that you want to multiply together, so if we take 37 multiplied by 16, we can partition the 37 into 30 and 7, and we can partition the 16 into 10 and 6. And then all we do here is we multiply each box. So 30 times 10 is 300, 7 times 10 is 70, 30 times 6 is 180, and 7 times 6 is 42. And then I've added together the top row, add together the bottom row, and then add them all together. And for some of you, you might think that's really complex and overcomplicated, and for some of your learners it won't work, but it will work for some of your learners, and that's why it can be a useful method. And I'll just very quickly, I'll just show you this quickly. If we had more time, I would get you to do it, but we don't have time. So just examples there. We can also use a similar approach for division. So this time we've got 792 divided by 6, and what we would do is we would partition the 792 into multiples of 6, and this is where it might be a wee bit more complex for some of you, whereas others might be like, yeah, this is great, I'm going to try this. So partition it into multiples of 6. The 192 is actually quite tricky to do mentally, so we'd further partition that, and you can keep partitioning it till whatever you want. So we've got 600, 180, and 12. So if we divide all of them by 6, we get 100. 30 and 2. If we add them together, we have 132. And I do appreciate we're totally rushing through this, and I know that you would like a wee bit more time in this. So as I say, the regional sessions are a time that we can possibly explore this a wee bit further, and Yvonne's got some information on that. And on that note, I'm going to hand over to you, Yvonne.
Thank you. Yeah, just a couple of slides to go. If you need to leave, you'll obviously be able to watch the recording for this little last bit. One thing we just wanted to point out is that at second level, there can be a lot of vocabulary that can be quite daunting at first, particularly if you're new to the stage. So we would recommend looking at the parents' own glossaries. It goes through each of these in terms of what they all mean. And also an important misconception to highlight at second level is the confusion that sometimes appears when you then start to introduce multiple calculations and learners are learning about the order of operations. And it can be confusing, and I'm sure you will have seen lots of things on the likes of social media, on Facebook and things like that, where there is a real misconception over multiplication and division and addition and subtraction. And this can happen when learners have been taught something like BODMAS without a real understanding of what it means. I'm sure you'll have seen the arguments where the likes of the division and the multiplication are in the same question. So we've put in a little link here to the Craig Barton blog, who explains this in more detail. You can see he's got a question up there, and in terms of what the kind of most common answer is to this. And it's really important, particularly if you're sending this kind of activity home, that parents have that understanding, because we often find it's a misconception for parents that they think, oh, it's BODMAS, division is always done first, or addition is always done before subtraction, and that actually that misunderstanding that the multiplication and division are on the same level, and it's to do with the way that, reading the calculation from left to right. There's lots of different online clips. We've included one to the BBC, which again can be sent home. It's good at explaining it. And also, just to highlight our Scotland Learns tasks, we wrote a number of these that focus on order of operations, so do check them out. There's some activities there that we've kind of written as part of the activities that we wrote during lockdown. And just to give you some further information, so the next session will be in January, and it is on a problem-solving approach, and we will pop the sign-up link on the next slide, and we'll put that into the chat for you so that you can sign up to it. And quite a few people on the evaluation put in that they weren't aware of the drop-in sessions. So Jacqueline, we could maybe just skip on to the next slide and come back to this one so that people can get that to sign up. But you'll see at the end of the presentation, there are the drop-in dates for your region. You'll find the information on Glow. So if you're not accessing Glow regularly, you probably have missed the notifications for this. I'll get Jacqueline to send round an email which tells you how to auto forward your Glow email to your main one. So for example, if you use a different local authority email account, you can make sure that anything that comes in, any tags on Glow, come through by email to that account. So we'll send that out so that people are not missing the information on Glow. So please make sure that you've joined the team. It looked like most people were in favour for keeping the drop-ins. It was maybe just a clash of time, people not knowing about it. So we will confirm it at the next session, but I imagine that these will go ahead because that was the response. Jacqueline, Maria and I, we will stay on at the end. Thank you very much for joining us tonight. We appreciate that this is a really busy term, and by this point you're probably flagging, trying to cram in all the personal life stuff around the work stuff. So we do thank you for giving up your time tonight, and we will hang around if anybody's got any questions. But thank you. Safe journey home in this weather if people have got a travel to make, and we'll see you all in January.